Imagine the absolute, monumental, logistical nightmare of trying to track humanity at scale. I mean, we're talking about millions of people moving, working, being born, and passing away literally every single day. How on earth does any government keep track of it all? How do they know exactly where to build the next hospital or how many textbooks a school district is going to need 5 years from now? In this explainer, we're going to unpack the fascinating, complex, and honestly surprisingly specific science of how the government counts people.
Just take a look at this number, 109,035,343. That's not just some random string of digits. That is the exact total population of the Philippines, as recorded by the Philippine Statistics Authority on May 1, 2020. Getting to a figure that precise takes an unbelievable amount of coordination and incredibly strict methodology. Okay, let's dive into this and see exactly how they pull it off.
To make sense of it all, we're going to peel this onion layer by layer. 1. The big count. 2. How governments collect data. 3. The engines of change. 4. Visualizing our demographics. And 5. Demography by the numbers.
Section 1. The big count. So before a government can even think about counting its people, it needs a framework, right? And that framework is demography. Demography is essentially the ultimate organizational tool for making sense of that giant starting number we just looked at. It's the study of statistics, we're talking births, deaths, income, disease, that illustrates the changing structure and composition of human populations. Basically, it takes the total chaos of millions of individual lives and translates it into structured, understandable data.
Section 2. How governments collect data. Now, demography is really only as good as the data it relies on. So how do we actually gather all this information? Well, there are 4 main engines driving population data collection. First is the census, which is a complete, total enumeration of everyone residing in an area. In the Philippines, the PSA is mandated to conduct this every 5 to 10 years. Second, we have the vital registration system. This data comes from local civil registrars who track every single birth, death, and marriage. Third are sample surveys, like the National Demographic and Health Surveys or the Labor Force Survey, which take a smaller, targeted sample to produce national estimates. And finally, administrative records. These pull data directly from agency operations. Think immunization records from the Department of Health or voter profiles from the Commission on Elections. Which brings up a really fascinating question. When a government says it's counted the total population, who exactly makes it into that enormous bucket? It sounds super simple, right? Just count everyone sitting in a house. But humanity is way more complicated than that. The reality is that the total population size at any specific time covers a lot more than just traditional families and private homes. The count actively includes people living in institutional quarters. That means individuals in prisons, dormitories, hospitals, and hotels are all tracked down and counted. It even stretches across international borders to include those stationed in embassies, consulates, and missions abroad. And the roles get incredibly, almost humorously specific. Take land-based overseas Filipino workers, or OFWs, for example. They're still included in the national count, but only if they fall within a strict 5-year cutoff reference period. And what if you literally spend your life working on a ship in the middle of the ocean? Well, don't worry, the government hasn't forgotten about you either. Seafarers are absolutely included in the total population count. It's just a huge testament to how meticulous the guidelines have to be to make sure absolutely no one slips through the cracks.
Section 3. The engines of change. Now that we know how we get that massive static number, we have to recognize that populations are definitely not frozen in time. They breathe, they grow, and they shift through 3 major demographic processes: fertility, mortality, and migration. Literally every single fluctuation in a nation's demographics can be traced back to these 3 core pillars. People are born, people pass away, and people move. Let's start with life. But real quick, we need to clear up a very common confusion between 2 terms, fertility and fecundity. Fecundity refers to the physiological potential of a woman to bear children, basically her reproductive capacity. Fertility, on the other hand, is the actual measured outcome. So the crucial point is that when demographers talk about fertility, they are strictly counting the actual number of live births that have happened.
And speaking of live births and mortality, the clinical definitions here are intensely precise. To be officially counted as a live birth, an infant only needs to show the briefest sign of life, a cry, the twitching of a single muscle, or even just the dilation of pupils. Even if it's just for a very short moment, that is a live birth. Conversely, when measuring mortality, a person who appears lifeless but is successfully resuscitated is decidedly not considered dead. These strict biological milestones are absolutely essential for keeping the data perfectly accurate.
Section 4, visualizing our demographics. So how do demographers actually map out all these births, deaths, and migrations so we can actually see the story of a nation? They use tools like the population pyramid. Now, what's really interesting about this slide is how its shape instantly reveals a society's structure by age and sex. Just look at the three main brackets here. At the bottom, we've got the young dependents. In the vast middle, we see the working age group. That's the economic engine of the country. And at the very top, the old dependents. By simply glancing at the shape of this pyramid, a government can instantly see if they need to build more elementary schools for a booming young demographic, or if they need to shift investments into elder care facilities for an aging one.
Section 5, demography by the numbers.
To truly utilize all this data, we have to look past the broad visuals and dig right into the actual math. If a population is constantly changing every second of every day, how did demographers mathematically track that growth or decline over time?
They use what's called the population balancing equation. It helps to think of this like a giant national bank account. P2 is your current balance. To find it, you take your previous balance, that's P1, and you add your deposits, which are the births and in-migrants. Then you simply subtract your withdrawals, the deaths and out-migrants. It's a pretty elegant formula that perfectly captures the whole concept of population change, boiling down millions of chaotic life events into a single solvable math problem.
And when we want to compare different populations, or maybe different time periods, we use formulas like this one to find the percent difference. This equation measures exactly how big one number is compared against another. By taking the difference between two population counts and dividing it by the original count, we get a percentage that tells us the relative difference. It's exactly how we know if a city's growth is truly explosive or, just a minor bump. Timing also matters immensely in demography. Because populations fluctuate all year long, demographers often need a standardized anchor point. This specific formula calculates the mid-year population, which estimates the precise size of a population area exactly as of July 1st of a given year. It gives researchers a really stable, consistent benchmark to use when calculating all other annual rates. From those benchmarks, we generate essential rates, which measure the likelihood of events occurring within a population exposed to that risk. We have things like the total fertility rate and the contraceptive prevalence rate. And when projecting into the future, demographers generally favor measuring geometric population growth. Instead of just a simple flat line, geometric change acts a lot like compound interest in a bank, compounding at constant intervals, usually every year. It's a much more realistic reflection of how human populations actually expand. But why do we do all this math? Well, because it literally dictates your reality, and this brilliantly illustrates exactly how. Demographers use these numbers to create vital, everyday ratios. How many doctors are there relative to the population? What is the ratio of hospital beds to the population? How many textbooks are available per pupil or teachers per student? These are not just academic exercises. These ratios determine where the funding goes, where infrastructure is built, and how a government actively plans for its citizens' basic needs. So, as we wrap up this explainer, I want you to really think about this. Everything you do, where you choose to live, the career you pursue, the family you might build, it all feeds directly into these massive equations. You are a vital part of this balancing act. If your life is just a single data point in this monumental demographic machine, how will your very next life milestone change the fundamental structure of our population? Keep questioning, keep learning, and I'll catch you on the next explainer.